All right, so let's get to it then. So, out of curiosity, how many of y'all are game developers or have done some game development? I'm curious. We got 2, 3, okay. How many of y'all do DevOpsy things? Okay, most of you guys. Cool, well, this is kind of an interesting crossover between those two domains. It's kind of weird when I first started looking into this area. There's not a lot of crossover between that for some reason. It's like kind of like you've got like all these different types of software over here, and then game development's kind of in its own little corner that doesn't have as many of those same types of practices in it. So yeah, so my name is Charlton Trezevant. I'm an application security consultant at Xspirit, but I do a ton of other DevOps things on the side. Here's our agenda for today. So how many of you guys have worked with GitHub Actions? We've got a couple people, so I'll keep the first stage, which is just a talk about GitHub Actions and an overview of its structure and functionality. Then we're going to jump into CI and CD for game development and what that looks like, what the needs are, how Actions fits into that whole picture. And then we're just going to jump into a deep dive for a real CI/CD set of pipelines for a game that my friends and I have built and are shipping. Alex, welcome.
Hi.
That we're shipping on Steam and itch.io, and it's built in Godot. So what are the goals as far as having CI/CD implemented inside of a game development kind of shop? So we want to have great experiences for developers as well as players. And it turns out that CI and CD are really key parts of that. So first of all, we want to reach players with a uniformly great experience on as many different platforms as possible. So whether they're on a Mac, whether they're on Windows, if they're buying a game from Steam, from itch, from Humble Bundle, Epic Game Store, we want our game to be as easily accessible to them as possible, wherever they are, meeting them where they are, and making sure that no matter what platform they're playing it on, it's going to be a really good experience. Now on top of that, we also want to have consistent and fast releases of updates and new content for our game in all of those different locations as well. And this is where automation is really important because, as you can imagine, if you're handling builds on many different platforms simultaneously, you need to make sure that they can be updated in a way that's uniformly consistent. So that's where making the release process as simple and automatic as possible is quite important, because we want to let developers focus on bug fixes and shipping new content instead of fighting the build system or having issues with the build system that they then waste a ton of time on. So let's just jump straight into Actions. So GitHub Actions is a generic workflow engine. It lets you automate anything that you'd like inside of GitHub. So you have these things called workflows. They're just text-based files inside of your repo. You write them in YAML. Actions themselves are just building blocks within your workflows, and they contain jobs, which are collections of steps. And each step has, say, a shell script or some action that it calls into from some other repository or within the same repo. This is kind of the anatomy of what a workflow looks like. So you can see some event fires, and that triggers your jobs, and then each job has steps inside of it. Those may be other actions, they may be shell scripts. Those execute on runners, which are machines that are ephemeral, and they're provisioned specifically to run the workflows that you've got that have been triggered. There are over 37 triggers currently for actions in GitHub, and triggers are just things that can cause a workflow to run. That could be something like a pull request or pushing code up to a repo, creating an issue, tagging an issue, creating a comment. There are many, many different ones, and it gives you a variety of different scenarios that you can target with automation and scripting with actions. So let's talk a little bit about the anatomy of a workflow, because this is important when we circle back to this later on. We're actually looking at these pipelines. So inside of the environment that Actions is running, and you have options for different types of runners that can execute your jobs. So you can run things on Linux, on Mac OS, or on Windows. And you can, for example, this is a screenshot of a pull request with a number of checks that have passed. That's why they've got these little green check marks. But you can have stipulations in your repositories, for example, with the pull request that, hey, I only want to allow this thing to be merged by somebody into the main branch if my linter runs and succeeds and these other status checks run and succeed. But it's all completely hosted for you in the cloud by GitHub. You don't have to manage any of the underlying infrastructure. You're just defining the things that need to execute on those. You also get a number of things around actions which make them easier to work with and more capable. So, for example, live logs, when your action is running, you get a stream of all the log output that is being produced by your workflows. There is a secret store that's baked into both repositories as well as GitHub organizations. If you've got things like API credentials and so on, maybe you're, in the case of the actions that we're talking about here, things like pushing to Steam or to itch. You need keys and credentials to do that. This is where you would store those securely. You can run on Linux, Mac OS, Windows, and you can also do containers as well, and you can do self-hosted runners. There are a number of different models for that. I'll talk about that in a minute. And matrix builds as well. We'll circle back to that. This is sort of what a workflow definition looks like in YAML. So you can see there's a name, there's a trigger, which is that on keyword. I know this is a bit small. And then there's that list of jobs nested underneath the jobs key. So that event is a push, so you can see that's defined there. And then here is kind of a visual layout of the jobs that are running. We check the repository out, install node, install bats, and run bats. So context and expressions. You may imagine, if you've written any types of shell scripts, you need variables and things to get information about the environment that you're running in, or store little bits of information as well. GitHub provides these for actions in this thing called contexts. So that is a set of values that you can use in different expressions throughout your workflows. Those can be used to create more elaborate values or to evaluate different types of conditions. Like you may only want a workflow to proceed if a particular step in like a previous job matches some condition, for example. Each of the steps that you have in a job can have different conditions that will be evaluated to be true or false when it executes, and you can control various parts of your execution through that. This is what the syntax looks like. So you get a $sign and then double braces and then whatever the context is. And then you can think of it sort of like an object. Like there's a context, so there's like GitHub dot whatever or steps dot whatever. And then there's the name of an identifier within that context that you're accessing essentially as a property of it. So GitHub will give you, the GitHub context will give you access to like workflow, token, job, event, etc. You can look at things like, I want to see the name of the tag that triggered the workflow to run, as an example. There's a context for information about the environment, so your environment variables and so on. And then there's a secret context, which lets you grab the values of secrets that you might need to use, your API keys and things that you've set up. Here's some examples. So if you've declared a secret called myAPI you would retrieve it from the secrets context using that first line. Same thing, that's another secret underneath, is Azure App Service published profile. You can name secrets whatever you'd like. And then this is what expressions look like. So if you can sort of read this, it's if, and then an expression, again, inside of that $, double curly brace syntax. So down here, we're checking to see if the GitHub ref is equal to refs heads main. And if that's true, then this would proceed, right? But that could be whatever you'd like to write. Matrices are cool. This is if you want to have a job item per element inside of the matrix. Don't worry about this too much because we're not going to be exploring that in the context of this talk, because Godot handles all of the builds for our different platforms inside of itself. But that's useful. For example, here it's like if you want to run a particular set of steps in a job for multiple versions of Node, for example, then there you go. Actions are reusable, they can be packaged, so you can get a ton of really useful ones from, say, like the GitHub and the action organizations, but you can also grab them from the community. You can publish actions from any public repository. There's a marketplace of actions that has over 16,000 actions, and they do all kinds of useful things. So say there's an action to set up a Node environment. you know, if you've got a node application that it needs to run, you would just run this setup node thing, or setup node action, and then all of a sudden you can run your code base in there, and so on. So a little more information about runners. This will be very relevant later. GitHub has a very nice set of hosted runners that they maintain and manage for you. Those are deployed from a set of base images that basically have like a large set of useful software packages installed on them. Those are hosted on Azure. That's the SKU. Again, GitHub manages everything completely. The only thing that's not hosted on Azure are the Mac runners, which are hosted on GitHub's own cloud. So here's the specs for the base runners. The Windows and Linux virtual machines have a 2-core CPU, 7 gig of RAM, and 14 gig of SSD space. Mac OS has 3 cores and 14 gig of RAM. You can get larger runners in a beta if you're like a specific type of customer. This is not generally available yet, but you have the option of going anywhere from 4 to 64 cores, from 16 to 256 gig of RAM, which may be useful if you have like a very heavy set of tasks that you need to run more quickly. But in this demo, we're just going to be using the base set of runners. This is a list of available runners you can find in the GitHub documentation. Again, there's a ton of pre-installed software on these runners that is quite useful for, you know, if you've ever had like a fresh Linux install and you needed to install like Build Essential and all those different types of packages for building software. A lot of that just comes out of the box on these runner images. But you can also self-host runners. So if you've got your own infrastructure that you'd like to maintain, you may do so. This is also useful, for example, if you've got specific hardware that you need to use as part of your workflows. Maybe you need access to like a GPU, or maybe you've got like some specific hardware device that you want to run like a build and then flash it to like a microcontroller, for example. You can put runners into groups and assign those groups to different repositories. So you could have like, you know, a set of build servers that are specific to one game, and then, you know, all of those have like whatever particular tool chain that you need to build and execute the game and its tests. Those communicate from your on-premise infrastructure up to GitHub. And there's various checks in place. Obviously, you would imagine that any kind of free compute service has some abuse associated with it, so GitHub likes to crack down on people trying to run Bitcoin miners. Here's what the logs look like for job runners. We'll actually look at that up close in a bit. And if you're familiar with Azure DevOps, this is kind of a comparison between the two. Pricing. So every organization on GitHub on the free tier gets 2,000 minutes of runner time per month. And there are different multipliers, or what they're called, associated with the other types of runners available. So if you use a Mac OS runner, then 1 minute of consumption that you would use on Linux is equivalent to 10 minutes, you know, against your free tier quota. And then that goes up from there. That's the pricing on the right. You know, obviously Linux is the cheapest, Mac OS is the most expensive, and then self-hosted is free. But we'll talk a bit about cost optimization strategies for the types of work that you'd see in game development. So, game development, let me do something really cool here. So I'm going to go over to my repo for my game. Right here it is. And I'm going to go to releases. I'm going to make a new release. We're going to call this version 1.0.8 stable. And I'm going to click this button. And I have just shipped, or I've just kicked off a job that will build and ship my game to Steam and itch, and go straight out to my users. That's literally all I had to do. So let's talk about how that actually works, because it's pretty cool. And we'll start by outlining some of the specific challenges that you see in a game development context. So game development is quite unique. The development workflow is really engine-centric, so everything happens inside of this. Like, you may be familiar working inside of like VS Code or IDEs and things. All of your work on a game happens inside of this really specialized kind of IDE that's specific to the engine that you're working with. And your code is not necessarily a first-class citizen there. It's more focused on, like, you've got 3D models and textures and assets and scenes and levels that are all living right beside that. So this is what that looks like, for example, if I were to pull up a project inside of Godot engine, which is what our game is built inside of, you can see that, like, I just opened this up. I don't even see a single line of code anywhere. I've got this weird, like, 3D kind of space that I can, you know, move some stuff around. Like, I'm moving this entire wall. I'll put that under the floor here. I've got all my geometry for the different things that are inside of this scene. You know, I can pan and tilt the camera around here. And then to actually pull up any code, I have to specifically go down and, you know, here's a script that controls, you know, the player's motion and sprinting. I can go up here and hit this play button, and this will go ahead and launch. This is just a little demo project. You can see I can run around and jump and do stuff. But yeah, it's quite different from what you may be familiar with, you know, in other contexts of software development. Because you can also jump off, you know, the side of the level into oblivion, which is something that you wish you could do at times writing software. But yeah, so it's quite a different workflow, quite a different tool chain. And then there are some other challenges around the actual building and the distribution. So you have large assets, right? You have a game that ranges from, you know, a few gigabytes to tens of gigabytes. And you need to reconcile that working with your repository, right, as your developers are actually working on the code base. There's a complex tool chain. Every single engine will basically handle its own build process, and they typically support a number of different platforms, and that's all integrated into them. You've got long build times, so even for our game, which is small, it only produces a final build of about a gigabyte, but it takes about 15 to 20 minutes to build. And the end result is extremely native-centric, so instead of, you know, building something and deploying it into the cloud, we're shipping large builds to end consumers that they're running on their actual, you know, personal machines. There's a diverse set of different targets in terms of consumer hardware, and there are many ways that things could break and not necessarily work. Console builds are another beast entirely that I'm not even going to talk about, but those are mired in proprietary SDKs, and it's very opaque. Like, you can't even find documentation on a lot of that because it's all under NDA, and people can't, like, talk about, say, how to build a game with Godot engine for the Nintendo Switch, because Nintendo will yank all of their developer licenses. And storefronts are difficult. So you may have used Steam, you may have used itch, other platforms where you can purchase games. Each of those storefronts has its own bespoke tool chain. And they don't want to, like, take your entire build every time, because you'd be uploading multiple gigabytes of basically the same data every single time you ship a new release to them. So they make you use their own custom tool chains to only send the parts that have changed, and then they reconcile the deltas back on their side. Again, engines are very special, and even for something like what I've just done in here, where I moved a wall around, it produces a huge diff, right, in the underlying code. So you end up in a situation where you've got all of this history that your Git repository is tracking, but it's not necessarily all readable or meaningful to just the human eye, the way that you might be used to, like if you're, you know, just writing, say, like a web application or something, and it's all very well considered. Like, this is something where you can make a very small change and it blows things up. So our end goals, again. We want to reach players with a great experience on as many platforms as possible. We want to have consistent and fast releases on every platform that we support simultaneously, and we want to make that process very simple. So, did we succeed in this? This is a text from my friend who's the lead developer of the game, and he says that it's so easy it feels like he's cheating, that's pretty good. So what are the different challenges that we were dealing with prior to having all of this CI/CD infrastructure built out? So we're a very small team. We're like 2 people that are actually developing this game. Really just 1, because all I do is the DevOps infrastructure. There's a ton of complexity and cost, because just shipping builds to Steam and to itch, that's like 6 distinct builds, because we're doing Windows, Mac, and Linux. And the itch build doesn't have some of the SDKs and things that the Steam build does to give people, like, achievements and so on. We have tons of platforms that we already are building for, and even more in the future. So as we expand the scope to support things like game consoles, for example, that's even more releases that we're doing that have other customizations applied to them. We want to have that consistency and reusability. So in terms of consistency, we don't want to have to worry about issues with the build system breaking the game. We want to keep those things separated so that we know that the build system will always work, and if we're triaging a problem, then it's somewhere in the game itself. And for reusability, obviously all of this CI/CD infrastructure that we're building out, we'd like to be able to reuse for other games as well. The quality and the player experience ties back to all of this because they're getting updates really fast. We're able to find and fix bugs super quickly. We pushed something like 3 point releases out on the first couple of days of the game being live, just because we have all this in place and it's super easy to do. It was just a couple clicks, and that new stable build is running as we speak. And then finally security, right? Because we're sending out builds of our game to something on the order of 250 players right now, and we are at least in part responsible for making sure that we understand what is inside of the sausage that we're throwing over the wall into their computer, right? So dependency management is an important piece of that. But yes, again, the scaling is hard. If we were doing all of this manually, it'd be a huge pain because it's the number of builds times the number of stores we're distributing builds on, plus the number of console releases that we're doing, which we haven't even broached yet. So the other considerations. Anyone can deploy. My colleague is not an expert at CI/CD, but I want him to be able to easily deploy stuff. So that basically 2-click workflow where we've shipped the update out to Steam is in effect the goal here is just making it where he can go do that at 2 in the morning and not have to worry about bringing me into the loop to make that happen. And I've talked about a bit of this, but another piece too is the feature flags and embedded information. So we're putting some feature flags into the builds to do things like managing whether the Steam SDK is enabled. There's certain performance optimizations that need to be on or off depending on the end target, and certain testing features as well. So we have debug builds. If we're trying to test new levels, we want to make sure that things like no-clip can be enabled by a tester so that they can easily get around a level or making the player invincible and so on. So we're going to go ahead and dive into just all these actions, workflows, and the code base of the game. But before I do that, any questions about GitHub Actions or what I've just described about some of the unique challenges of game development itself? Sure.
So I imagine that as you did describe some of these simple actions, like say you just make an acceptable request and it uploads a stable version of the game. But as the game scales higher and higher, I imagine there might be some actions that you have to continually manage and modify to.
Sure, yeah. So I can actually show you. This is our Git repo where we've got all of the code for our game Ibis AM inside. It's this guy. And if I go up to this Actions tab, can you see this? Is this visible? Yeah. Great. So you see these orange guys that are running? Those are actions that are currently executing. We've got this build and release stable channel for Steam, and we've got this other build and release stable channel for itch.io. If I click on one of these, I can go to one of the jobs and see here's the build that's running. It has already completed the process of building the game in Godot Engine, and it's now uploading the finished zipped executables to GitHub to run the next stage. So we'll come back to these in a moment, and I'll show you what that looks like when all the lights are green. Over here on the sidebar, this is a list of all of the different actions workflows that we've got in our repository. So we've got a beta channel that runs for Steam, and then 2 stable channel build release workflows for itch and also Steam. I've got one down here for building whatever is currently at the tip of the branch, and then one that formats the script. So the scripting language in Godot Engine is called GDScript, and then this can be manually run to basically run an automatic formatter against all of that. So explaining all of these, this tip build one, basically it runs anytime you've pushed changes to the main branch or to the secondary branch, and this will just build whatever is currently at the tip. So if my colleague is making changes or fixing things in the game, I can see whatever the current most up-to-date version of the game that we have in the repo, what that looks like, how it runs, and so on. If I click into this one, I can go down here and I can see these artifacts. So these are the things that are being uploaded right now by that workflow earlier, And I can click on either one of these and it'll download the zip file that's the result from the workflow. You can see here I've got builds for Windows and Mac OS. But if I go to, say, the beta channel for Steam, here's one that ran yesterday. I can scroll down and you can see I've got artifacts that I've produced for the web, for Linux, Windows, and Mac OS, all available here for me to download. So this workflow to build the stable version has not completed yet, but I'll go ahead and show you what it looks like in the back end of Steam, once this does end up there. So if you guys have ever published a game to Steam, you may be familiar with Steamworks. The UI and UX could use a lot of love, but you're able to, as a developer, to set up different branches that users can opt into. We've got a beta branch here. About 25% of our user base are using this. And you can see that I've got build IDs associated with each of these branches. These are assigned uniquely to each build that Steam receives from you. So if I scroll down to this list of builds, here is the beta build for version 1.08 R2, and here I've got it set up with the commit SHA. And that's what's currently published to that branch. The other ones are on 1.07 stable. Once our workflow that I showed earlier is completed, we'll see 1.08 stable appear in this list, and then we can set it where it will be live. So here's an example of a completed run of one of our workflows. So you can see that the job is set up, and then we run the build. If I expand this, there's a ton of console output, right? But this comes from every stage of our workflow file, which I'll show you in a moment. The total runtime for this was 18 minutes. And then after that, we had a 10-minute run for this release step that actually takes the finished artifacts from the previous step and uploads it into Steam. So here's our workflow file for the beta channel release. All of the workflows associated with the build and release for all of our game CI/CD is fairly similar. Because it calls against the same actions just with different parameters to identify those builds as being, say, a beta build or going to whichever storefront. So you can see that anytime we publish a release, we're going to trigger this workflow. And I've got this neat cost optimization strategy that I'll talk about later on with concurrency groups here. We set up a couple environment variables. So earlier when we talked about how you can pull in values from those contexts to build other values that contain them. Here, for my beta builds, I want to have the name of my release tag, dash beta, dash whatever the SHA of the commit associated with that tag is. And where I use that in the game, so if I load this game, and it'll take a second to get through the really cool intro that we have set up. This appears in the credits screen of the game. So that means if I go select this credits in the menu, here's my build info, right? So I can take an arbitrary copy of this game and kind of work backwards to see where it came from and how it was produced.
Is this a low res, what you were showing? Is this kind of a low res?
Yeah.
Or is it just a projector?
No, that's like an aesthetic choice from the designer.
Oh, okay.
Right, so here's our list of jobs. So this workflow file contains two jobs. We have a build game and we have release Steam. Build game does exactly what you would expect. It builds the game. There's a condition here that checks to make sure that the name of that tag does not end with -stable because this is a beta workflow, so we don't want stable releases to trigger a beta workflow. Notably on this, this trigger here, if you're triggering on the creation of a tag, then you can filter based on the structure of the name of the tag. But for triggers that are based on the name of a release, that's not something you can do. So you have to use a condition like this. And then we call into this build Godot action here with all of these different parameters. The second job that we've got is this release Steam. So this has the stipulation that the previous job must complete before it will execute, because obviously we can't upload files that we have not completed making yet. to Steam, and then that calls this action release game with all of this configuration. And I'm just going to kind of go down the layers here.